Here we are. We're going to deal with systems of linear inequalities. So we're going to start out with just one inequality at a time and build up from there. Okay. These, by the way, are videos. These things that have these little marks over here. And remember, you get points, homework points for watching the videos. These are really short. The ones that have these little arrows, they're really, really short and very informative. Okay, question 1. We have talked about this. I mean, you all in other classes have talked about these. You were introduced to them briefly in beginning algebra or algebra 1. We're going to carry them forward today, but let's do a few little one-offs right now. There's a method you use for this, to solve this. Notice it's not y equals 3x, which would be a straight line. Instead, it's y is greater than 3x. So this is number 1 in your homework. Number 1. All right, we're starting off with y is greater than 3x. Okay, now there are 2 parts to graphing inequalities. First, you graph just the straight line. Well, that's not how you do it. You change the inequality sign to an equal sign. Then you find 2 points. You graph it just like a straight line. These are all straight lines. So how would I do that? I might put this in my graphing calculator and find some points, or I might do it the easy way, the lazy person's way, which is I put down 2 really easy numbers for x. So maybe I'll let x equal 0 and x equal 2. How about that? I just pick those numbers out of the air. I could pick any numbers, but I just want to keep them small. They're easier that way. All right, so if x is 0, then y equals 3 times 0, because we've got 3x. So that's 0. 0, 0 is one of the points on the line part of the inequality. That is so good. Okay, now, if x equals 2, then y equals 3 times 2, which is 6. Now I've got my 2 points. That's great. Now I'm going to make a quick little sketch on my paper, and I'm going to transfer it to my math lab, but I want to do it on my paper first just to kind of get a feel for it, and so that I can talk about it and label it. So I'm just going to make a quick little graph here. Hope I have enough points. Okay, now I'm going to graph the line, but we have to talk first. This is called a strict inequality. Whenever you have an inequality that you're going to be graphing, and it's a strictly greater than or a strictly less than, your line is going to be dashed. It's not going to be just a line. It's going to be a dashed line. So we'll see how you choose that on my math lab if you haven't already done that. Anyway, let me find the points. Do it in blue. 0, 0 is right here. And 2, 6 is 1, 2, 1, 2, 3, 4, 5, 6. So that this is 0, 0, and this is 2, 6. Now I'm going to draw a line between them. I'm going to draw a line, but it has to be a dashed line. So I don't get to, choose one of my handy dandy lines over here. I'm going to have to actually do this by hand, and it's liable to not be really very pretty. Okay, best I can do. Now comes part 2. This was part 1. Drawing the line. But it's got to be more than that. If I had y equals 3x, this is how I would graph it, and I wouldn't even bother to make it dashed. But it's really an inequality. So when you graph a linear inequality, you also have to shade one side of the line or the other side of the line. So now, shading is part 2. We have to find out which side to shade on. Okay. I need a test point. A test point is any point on the grid that is not on the line. So any point not on the line. You can just kind of shut your eyes and pick a point. How about here? I have not done this ahead of time. I have no idea what that point is going to do for us, but let's find out what it is. -1, -2, -3, 1, 2, 3. Okay, this is the point, -3, 3. And that's going to be my test point, my TP. Now, my inequality is y is greater than 3x. So I take the x coordinate from the point and I put it in for x, and the y coordinate from the point and I put it in for y. And what I get is 3 is greater than 3 times -3. So 3 is greater than -9. And that's true. But you can prove it to yourself. I'm going to show you how. Just look at the x-axis or at the y-axis, but x is easier. 1, 2, 3. 3 is here. Now, -9 is -1, -2, -3, -4, -5, -6, -7, -8, -9. Here's -9 over here. Notice that greater than also says to the right of. Is it true that 3 is to the right of -9? You bet it is. So this is true. We get a true from our test point. What does that mean to me? What that means to me is that this side, the true side, is going to be the side I shade on. Now, if I were doing this by hand, I would be finished, I would be done. But I have to transfer this to my math lab. There, that's a good enough view. Okay, now we're going to graph, and here's how. Click. Okay, the first thing you do is you tell my math lab, hey, I'm going to graph a straight line. And here's your icon for a straight line. Then you're going to tell my math lab, the line I draw has to be dashed. And that's where you choose these. The default setting is a regular kind of line, but you can choose a dashed line right there. Click. Now I'm going to have a dashed line. Okay, now I need my 2 points, and I've already calculated those. The point 0, 0, see up here on the yellow banner, it says click the graph to plot the first point of your line. Now, if you look up here, that's a good way to double check that you really are on the point you want to be on. I want to be on the point 0, 0. Click. Now I'm going to change to the point 1, 2, 1, 2, 3, 4, 5, 6. And there's the point 2, 6. Now, I'm not done. Normally you would just hit save. You have to shade on one side of the other or the other, and I know what side I'm going to shade on. So here's a paint bucket. I drag my paint bucket over here to the side I want to shade on, and then I click. Now I'm going to save. Then I'm going to check answer. And that's how you do this. This is what makes a linear inequality different from just graphing a straight line. Now let's do this one. Oh, okay. Yes.
I actually, yeah, I have a question.
Great.
For step 1, where you were trying to find your X and Y coordinates to just graph a line, were you able to just pick any X and Y coordinates you could think of, or do they have to be like certain X and Y coordinates?
That is a really good question. What I did was, since I have this in terms of Y equals something times X, the Y is by itself over here, and the X term or terms are over here. The easiest, quickest way to do this is to just pick any 2 numbers in the universe for X. So I chose 0 and I chose 2. But then I had to find out, okay, if X is 0, then what is Y? So I had to actually take X equals 0 and put it in for X and calculate what 3 times 0 is, and that gave me my Y coordinate. And the same thing for 2. If X is 2, then I put a 2 in for the X, and I get 3 times 2, and that's 6. So that's how I got the 2 points. I didn't have to choose those two numbers for X. I could have chosen -3 and -1. I still would have gotten points on this line.
Okay, thank you. That answers my question.
That's great. Any more questions?
No, I think I'm okay with the rest of this.
Okay, what about anybody else? Okay, let us go on down to number 2. This is going to be a little different because this was a line and slope-intercept form. So all I had to do was choose x's. Now, with this problem right here, this is a line in standard form. So you're going to see that I treat this a little bit differently. Okay. Actually, it's not in correct standard form, but it's kind of sort of like standard form. In correct standard form, your y term is that true? No, this is correct standard form. Don't pay attention to me. I'm going to have more coffee. Oh. Okay. Now, again, the first thing I'm going to do is change this inequality sign to an equal sign. And just graph the line. That's the very first thing I'm going to do. Okay. Now, I am going to make an X and a Y table, but I don't have to. I could also go ahead and change it to slope-intercept form and put it in my calculator and find 2 points that way. But I'm going to stick with my X and Y form. Now I need I need an X coordinate and a Y coordinate that I can put in here and come up with -8. Notice this might not be easy. So let's see. I'm going to kind of be thinking. I know that 6 plus 2 is 8, so -6 minus 2 will be -8. So if I were to let x equal -2 and y equal 1, I would have 3 times -2 minus 2 times 1. That would be -6 minus 2, and that would be -8. Boom! That's our first point. Now I have to come up with something different. Okay. I would really like, if it's possible, to have 3x equal something, you know, so that when I divide by 3 and divide by 3, 3 will go into this evenly. How could that happen? Well, 3 will go into 6. 3 will go into 3, of course. This is not going to be so easy, but so, you know, I don't always get what I want, and I have learned that. There is something else that would be easy, I think. Yes, it would. look at this situation. What if x were 0? Then look what would happen. I would have 3 times 0 minus 2y equals negative 8. 3 times 0 is 0. So that would be negative 2y equals negative 8. Boom, negative 2 goes into negative 8 evenly. So y equals negative 8 divided by negative 2 is positive 4. Notice I'm allowed to choose one number, but the other number I have to calculate in. It can't just be 2 totally wild numbers. It can be one totally wild number. But anyway, see, it's just like working with the matrices. Your brain is clicking and you're saying, well, how can I get this? What are my possibilities without having to work really, really hard? So there I go. I now have my 2 points, negative 2, 1, and 0, 4. And so I am going to make a quick little graph on my paper, because it's just, it's just easier to kind of work out all the kinks on your paper. All right. Okay, so I'm going to plot my points, but since this has an equals to bar underneath, this is less than or equal to, this is going to be a solid line. And you get a solid line whenever, I always forget, whenever you have that bar underneath your inequality signs. Okay, that's a solid line. So I don't have to worry about dashing, and that makes me happy. So now, negative 2, 1, negative 2, positive 1, and 0, 4. 1, 2, 3, 4. And now since the line can be dashed, solid, it's just quicker, for me anyway, with a tablet. You people who have tablets, you can relate to my dilemma here. Okay, great. Part 1 is done, assuming I'm correct. Now we're going to change to part 2. Which is going back to what I'm really dealing with, which is 3x minus 2y is less than or equal to negative 8. I need to choose a test point, which can be any point not on the line. Well, my favorite point to choose as a test point is 0, 0. Because then x is 0 and y is 0. So I'm going to do that. That's going to be my test point right here. My TP is going to be 0, 0, which means x equals 0. Might as well write it out. and y equals 0. Why do I want to write it out? So that I can come over here and put a 0 in for x. You don't have to use 0, 0. I just like it. Because I'm lazy. Well, this is going to be 0 minus 0 is less than or equal to -8. 0 is less than or equal to -8. What this also says is that 0 is left of 8. -8. So we have to see if that's true. -8 is -1, -2, -3, -4, -5, -6, -7, -8. Here's -8, and here's 0. This says 0 is to the left of -8, but that's not true. So, uh-oh. 0, 0 gives us a false. What to do? What to do? Simple. You're not going to shade on this side. Don't shade on this side. Don't shade on this side. But then what'll I do? Where can I shade? On the other side. Don't shade on this side. Shade over here. So, okay, I'll do that. Ta-da! Okay. Now, I'm going to transfer all this knowledge over here. The graph part, you know, with points is going to be a straight line. So the points I used were, here they are, -2, 1, and 0, 4. Okay, so I go over here. See how that, look at the upper right-hand corner of the yellow bar. Look at that. Wherever you go, it tells you where you are. I think that's great. -2, 1. And 0, 4. Okay. Now I know I'm going to shade over here, or I hope I am. Click. Now I'm going to save, and I'm going to check. I was betting I'd get it wrong, because I was just moving too fast, or I felt like I was. But good, I'm always glad when it says, good job. So let me pull this over and save it while I'm at it. I already saved it. I feel persecuted by my computer. I don't know how many of you feel persecuted by your computer, but I feel persecuted. Because there it is, right there. I did change the name. Ooh, okay. Well, I'm in the wrong place then. Here you guys are. Okay. Now, here we are with another kind of inequality. Now notice, one is, hello George, one it's in standard form. This was in slope-intercept form. This is in standard form. So that automatically means your thinking has to shift a little bit. However, because 3 does not go evenly into 8 or -8, and 2 or -2, oh, well, it does go evenly. We did have to be more creative in our choice of points. So there was that difference. It wasn't just a quick and easy deal. We had to actually work a little bit. But we still had part 1, find the points, graph the line, and part 2 is shade on one side or the other. And now we have always shade on the true side, because you're guaranteed if this side gives you a false anywhere over here, then this side will give you a true everywhere over here. Okay, questions, discussion. No. Okay, cool. Let us move on. We are now going to do this problem. And I don't know if you can see that really well. Now you can't. But now you can. Yes, and over here you're going to have, you don't really have to physically graph, but you do have to figure out what the lines are, and actually the lines all look the same, so what side you're going to be shading on. So this is a system of linear inequalities. Okay, the variables are all raised to the 1 power, because you don't see a power, it's to the 1 power. And as long as all the variables are to the 1 power, you're dealing with a straight line. Okay, now we're still going to go through the same steps, but of course now there are 2 of them we're graphing together. So this is number 3 in your homework. Yeah. All right, fine. Number 3. Here are our inequalities. Y is greater than or equal to, I always make that slanted. It's just the way my teacher did it. So, you know, you pick things up and they stay permanent. That's how things go from one generation to another. And Y is, let me try to do it the totally correct way. There. Well, all right, I give up. 1 minus X. Okay, here's how I do it. Let me make sure this is right, though. Okay, now notice your lines are going to be solid lines. Now, what I like to do and what I strongly recommend is that if you are a parent or if you have younger siblings, steal their crayons or colored pencils. You're bigger, so what can they do? I've learned that from my cats. The bigger one always wins. I did learn from parenthood that's not always true. Anyway, Y is greater than or equal to X plus 3. And oh, this is really my favorite color. y is less than or equal to 1 minus x. Okay, now I've got two colors going here. It also makes it more fun. And for those of you who don't really like math, you might as well do whatever it takes to make it more fun. I am going to treat each of these with the two-step method. So step 1, y equals x plus 3. I find 2 points. Doing this is always easier when you've got slope-intercept form. All you have to do is choose your x's. So, I mean, I could choose any numbers, but I like them easy. Is that such a crime? 0 and 2. Maybe it is. If x is 0, then y equals 0 plus 3, which is 3. And if x is 2, then y equals 2 plus 3, which is 5. Oh, which is 35. Of course it is. There. Two plus 3, which is 5. What a difference an equal sign makes. Okay. Now, I am going to come down here and make a grid. Not a big official grid. Remember, you've just got a pencil or a couple of colored pencils, and you're just doing something very unofficial that nobody but you will see anyway, probably. And now this is the reason for the different colors, is so I don't get my lines all mixed up. Okay, 0, 3 is 0, 1, 2, 3. And 2, 5 is 1, 2, 1, 2, 3, 4, 5. And since it's a solid line, it's much easier for me to use my line tool. Incidentally, for those of you who would, like to have a tablet that'll do this, or that you can do artwork on, the Wacom, WACOM, is very reasonably priced. Here's what it looks like. Very reasonably priced. I love it. I absolutely love my Wacom. Don't want to upgrade. I like it just the way it is. Okay, step 2, which side am I going to shade on? Now, please notice that I am not going to do the graph over in my math lab until I'm completely finished over here, and you'll understand why when I'm done. Step 2. I always do that. So predictable. Step 2. Go back to the inequality. Y is greater than or equal to x plus 3. Okay, so I can make 0, 0 my test point. So if my test point is 0, 0, then what I will have is 0 is greater than or equal to 0 plus 3, which means 0 is greater than or equal to 3. I don't even need to graph that to know that 0 is not greater than 3. So this gives me a false for the blue line. That means I go over to the other side and graph over here. I don't have the equivalent of a paint bucket on here. That's not the Wacom's fault. That's the fault of my PDF editor. But I also love my PDF editor. Let me save. Okay. I'm done with that line, but I'm going to wait. I'm also going to graph this. Step 1. Y equals 1 minus X. Find 2 points. Or, yeah, don't complicate things, Barbara. I'm going to let X equal 0 and 2 and see what happens. If X is 0, then Y is going to equal 1 minus 0, which is 1. And if X is 2, then Y is going to equal 1 minus 2, which is negative 1. So, I am going to plot the points 0, 1, and 2, 1, 2, negative 1. And that 2 is the kind of inequality that will let me use a solid line. So, no. Try again. Okay. Now, step 2. This is really Y is less than or equal to 1 minus X. And notice I could choose 0, 0. But, you know, let's just choose a different point. How about negative 1, negative 1? So if, notice it's just easier though if your X and Y are the same. They don't have to be, but I'm just looking at easier. I'll have negative 1 is less than or equal to 1 minus negative 1. So negative 1 is less than or equal to 1 plus 1. So negative 1 is less than or equal to 2. Well, I know that negative 1 is less than 2, but if I doubt it, here's negative 1, and here's positive 2, and negative 1 is definitely to the left of 2. Notice the arrow is pointing to the left. So this is a true statement, which means for the violet, it's actually a violet line, we're going to shade on the true side because we have a true. There. Okay. Red and violet simply do not go together, but that's pretty cool. All right, now here's the reason I waited. The solution to this linear inequality, where I drag my paint bucket, is going to be where the colors overlap, where the blue and the red are together, and that's over here. So now look at the situation. I have my blue points. I have my red points. Let me write them in an easier to see way. 0, 1, and 2, -1. So the first thing I'm going to do is graph both my lines, and oh, I don't have to do that. All I have to do now is find something that looks like this. Didn't even think of that. Okay. This is where the shading is, right? Yes. Over here. So I'm going to choose D and then check my answer. Oh, good. Okay. Questions about this? Okay, I didn't hear any. Don't be shy though. That was number 3. Number 4 includes one more step. Hello, there it is. Number 4. Let's look at number 5. And number 6. I wonder if we should do 6. Let's do number 4. Okay, there's one more step. Well, first you've got to actually graph it. We can do that. But next, find the coordinates of the vertex. When you're dealing with systems of inequalities, where the lines cross is called a vertex. Now there is kind of another step to that, but you'll deal with that in finite math. So for now, we're just going to have a very limited definition that the vertex, when you're dealing with systems of inequalities, linear inequalities, the vertex is where the lines cross. So we're going to find the point of intersection. That's the extra step. Okay, so here we go. Number 4. Y is less than or equal to X. And I'm going to use green this time. Y is greater than or equal to 4 minus X. And this is number 4. All right, fine. Not going to deal with it. We're going to use the same exact steps because first you graph it. Y equals X. This is very famous. You're going to learn more about this line. Suffice it to say it's a famous line. It's like the mother and father of all straight lines. This is where they come from. This is the generator of all straight lines. Take my word for it and I'll show you in a few weeks. But easy here to find points. Whatever Y equals X equals, whatever X equals Y equals. This is also called the identity function. So I could just say, okay, how about 1, 1 and 5, 5? That's quick. Not usually that quick. Step 2. We're going to have y is less than or equal to x, and I actually have to have a little picture before I can decide on my test point. So, yeah, let's do this. My cry of pain. Okay, now let me plot my points first. 1, 1 and 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Did I have to choose those points? No. Could have chosen any points, but they would have been the same for this function. Okay, so I'm going to graph a line. Notice 0, 0 is also there. Which eliminates my being able to use 0, 0 for this line. That's not perfect. All right, now, so there's my line. You see, this eliminates my being able to choose 0, 0. So it's important that I graph the line first before I decide. This one looks good. What is that? -1, -2, -3, -4. Actually, I could make it that if I wanted to. But -4 and 1, 2, 3, 4, 5. So we have the point -4, 5. And that's our test point. Now, y is 5. X is -4. 5 is definitely not greater, 5 is definitely not to the left of -4, because here's 5. Here's -4. 5 is to the right of -4, so there should be a line going that way. Make sure it's not. Nope. Okay. So, I mean, this is just totally wrong. This gives me a false for the blue line, which means I shade over here. Really, Barb. There is really no great hurry. Relax. We are right on time. Okay, now we come up here. Going to use the same methodology. 1, this is y equals 4 minus x. I could choose 2 points for x. How about 0 and 4? Or I always use 0, don't I? How about 2 and 4? I do prefer positive numbers just because they're easier. I could have made it -2 and -4, or -2 and +4, or any numbers I want. So make them as easy as possible. If x is 2, then y is going to equal 4 minus 2, which is 2. And if x is 4, then y is going to equal 4 minus 4, which is 0. So, 2, 2. Is there anything wrong with that? No, not at all. 2, 2, and 4, 0, right here. Now I need another test point. For sure, I could use 0, 0 for the green line. Let's do that. Okay, so my test point, oh, yep, 2. Okay, we go back to y is greater than or equal to 4 minus x, and if 0, 0 is my test point, then I'll have 0 is greater than or equal to 4 minus 0. So 0 is greater than or equal to 4. That's definitely false. Definitely false. So 0, 0 gives me a false for the green line, which means I shade over here. And I can already tell where the overlap is going to be. Over here. Now I'm not going to worry about the vertex yet. I'm going to go ahead and graph this first, because they're almost always two separate questions. Straight line. 1, 1, and 5, 5. Okay, now you've got to graph the lines first. 2, 2, and 4, 0. Click the line again. 2, 2. And 4, 0. Now, check one more time, down here. Okay. All right, the die is cast. Good. Now we find the vertex. the vertex is at the intersection of the line y equals x and the line y equals 4 minus x. So we solve them together as a system to find the point of intersection, which is what the vertex is in this context. I think I'll calculate over here. So we've got y equals x and y equals 4 minus x. Double check. Yep. Okay. Now, notice this. I'm going to use substitution because I think that's probably the easiest way. If y equals x and x equals y, I could say, okay, well, I mean, y and y are the same thing here. So if y equals x and y equals 4 minus x, then y equals both of them, right? So x equals 4 minus x. Add x to both sides. Two x equals 4. Divide by 2, divide by 2. X equals 2. That looks right. Now, if x equals 2, that means y equals 2. So the vertex should be the point, and it sure looks like it, 2, 2. Let's see. Two, comma, 2. Oh, I missed it saying I was fantastic. Let me revel in that for a minute. Okay. Discussion. It's so much easier to do it this way. By making a quick little graph on your paper and then transferring that, because it's got to have all the information already, it'll have 2 points for each line. And you'll be able to see where the shading is. The alternative way to find the shading is to pick a test point in each of these pie slices. And then test that point in both of your inequalities. And whichever point gives you a true here and a true here at the same time, that will be where you shade. Now, to me, that seems like a lot more trouble. But to some of you, you might prefer that. So notice that if I pick any point over here, and this, it looks like it's the point, let's see, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4. 11, 4. If I test that in both of these, okay, so we've got the point 11, 4. Then and y is less than or equal to x, you'll have 4 is less than or equal to 11, which is true. And in y is greater than or equal to 4 minus ugly 4, 4 minus x, you'll have 4 is greater than or equal to 4 minus 11, which is going to be -7, so 4 is definitely greater than a negative number. A positive number is always greater than a negative number, or you can find them. You know, here's 4, and -7's over here, so 4 is definitely to the right of -7. So you see you get a true and a true. And in each of the other slices, you'll have a true and a false and a true, and a false and a false. So that's a possibility also. But I just like doing this better. Discussion.
I do have a question.
Yes.
About this specifically, it's about the test.
Ah, okay.
I wanted to know how many questions were going to be on that.
There are 25 on the exam.
Okay, and is that the same amount that's on the practice exam as well?
No, there are more on the practice exam. There are 33.
Okay, I got you. Thank you.
You're welcome. Anything else? Well, we have 5 minutes. I don't see starting another problem and having it only go 5 minutes. So why don't I declare class over, and then as usual, people who have questions can hang around. And I'll hang around. And then at 9 o'clock I go over to the to my help hours, my help time.